Hello, in this video I will show you how to simulate ion implantation in Monte Carlo code called SDTrimSP, which is based on binary collision approximation, and how to perform its simulations within the graphical user interface. So let's first take a look how to compile the code itself. The manual how to do it is also mentioned on the implant team website, and the link is here. And to obtain the code, it is not freely available, but you can get it with the corresponding license if you contact one of its author, Dr. Mutzke. The email is mentioned here. Okay, so let's suppose you have the code and you extracted it. You will have probably a slightly different version than mine, but likely the compilation process will be the same. To compile the SDTrimSP, we need to first have some prerequisites. I will copy the commands here, which will update my Ubuntu and upgrade it, and also install some basic packages. That was very quick because I did it before. And after this, we also need to have OpenMPI for parallel computations. How to compile OpenMPI is here, and there is also a video how to do it on our website. You can find it at this link. I did this before, and after it's finished I need to activate this version of OpenMPI. I will activate it temporarily by exporting its binaries and libraries with this command. And to make sure I did it correctly, I will check my version, and yeah, it's corresponding to the path of this OpenMPI. Okay, so we have all prerequisites, and we can now directly compile SDTrimSP. Let's navigate to the bin folder inside the main SDTrimSP folder. And inside this folder there are different versions with different compilers for the compilation. In my case I will use the parallel compilation with GCC compiler. So I will navigate here, and there is the script which will provide the compilation. I will give this script the rights to be able to run it, and then I will simply run it. It will not take much time, and once it's finished there will appear more files inside this folder, and one of these files will be the executable file for SDTrimSP. Yeah, the executable file is this one. So once I've done this, optionally I can export the path to this folder to be able to run this code anywhere inside my Ubuntu. So now that I finished the compilation of SDTrimSP, I will show you how to run its simulations within graphical user interface. And for that I will need to compile another code which is called BCA-GUIDE. It's a Python code, so I will need new prerequisites for that one. And I cleared my environment and moved to the initial folder, the main folder, where I compiled SDTrimSP, and here I will also want to compile the BCA-GUIDE code. To do it, I will activate a virtual Python environment to avoid any potential conflicts between different versions of packages. For that, I will use this command to activate my environment, and I will call it like this. Now I created the virtual environment, and I will activate it with this command and the same name. Activate. Yeah, and you can see it's activated. And for this virtual environment I will install these necessary packages. Let's wait until it's finished. Okay, it should be done. Okay, so that's all for the prerequisites. And now directly to the compilation of BCA-GUIDE. I will download it from GitHub using this code. It's done, and it's already extracted. So I need to navigate to its folder. And inside its folder I need to navigate to the setup folder, and here I need to run this installer using this command. And this will provide all necessary installation. It will be very quickly done. Once it's done, it will create an executable which will open the graphical user interface. It will be called like this. Okay, it's finished. I will check if the executable was created, and it should be one folder above, and yeah, it's here. So again, optionally I can export the path to this executable, so I can run it anywhere. For now I will not do it. I will test it if I can run it, but just first I will rename it. So it's shorter. Let's just call it BCA. And to run it I will just use this. Yeah, BCA. Yeah, it's working. Okay, so now let's configure the SDTrimSP in this graphical user interface. First I have to select configuration title. Let's call it example. Then it shows me certain predefined simulation versions. Mine is different, it's 7.01, which is not here, but it still works. I need to select the main simulation folder of the SDTrimSP. So let me find it, the one that I just compiled, and this is the main simulation folder. So I will choose this one. After that I need to select the simulation binary, so the SDTrimSP.exe, and it's here. Okay, I will save this configuration, and now I can change the simulation settings of ion implantation as I want. So let's simulate certain example that I prepare on my website, my team, and it will be the simulation of nitrogen into this high entropy alloy. And so in this window I will set the parameters of the implanted beam, and I will find the element nitrogen, select it, and it will automatically fill certain predetermined parameters for this element, like its atomic mass, the atomic density, but this parameter I will need to change to correctly reproduce density of my modified target with nitrogen, and it filled surface binding energy and displacement energy. If I need, I can change the model for the electronic stopping power, and it shows me 6 options. I will keep it on the predetermined one. Okay, I can also change the incident angle, but let's keep it perpendicular, and I can modify the implanted energy, so let's say 5000 electron volts. After the beam, I can set the target. First of all, I can change the thickness of my target. 2000 angstrom should be enough for this energy. I can modify the target segments, so basically how many intervals will be within this thickness. And I can change the target composition. So I need to fill all the 5 elements for my high entropy alloy. So the first one, second one, third one, fourth one, titanium, and fifth one. And it also automatically filled all the parameters. But in this case, I want to change the atomic density so that each of these elements have the same within my target. And I will suppose that each element has this atomic density. So change it 68, copy it for all the elements. Okay. And also I need to set initial concentration of each element within my target. So let's suppose each of them will have 20%. Yeah. And this is all for the beam settings and the target settings. And I can select another parameters of my simulations. So I can decide if I want to simulate the static mode, which means that the atomic density of the target will not be changed due to the implanted nitrogen or due to the sputtering effect. Or I can select the dynamic one, which will consider these effects, and the material density will be gradually modified. Okay, let's simulate the dynamic one. I need to set the number of histories and number of simulated projectiles per each history, so let's reduce it in order to be quickly finished. Here I can set 500, for example. Then I can set the maximum simulated fluence for this case, like 5. I can modify the interaction potential, so either KRC or ZBL should be fine. Let's set it as the default one. Also, I can modify the integration method if I need, and I can change the model for the surface binding energies. I will also keep it as the default one. And that's all for the settings. And now I can run this simulation. It will ask me where to save the output files. Okay, let's create a new folder for that called example. Okay, example, I already tried it before. Let's call it example 2. Choose. And you can see the simulation is running, and I can already preview the results. I can visualize the atomic concentration for each element depending on the simulated fluence. You can see, and I can see how it's changing with the implanted fluence. I can also visualize the sputtering yield for each element depending on the fluence, total sputtering yield depending on the fluence, or for example the surface concentrations for each fluence, or how much surface was erased due to the implanted nitrogen with each fluence. And all of these data were saved in the folder that I set, or I can also preview the data here. For example, the atomic concentrations for each fluence I can see in this file, and I can show the all data and do whatever I want with them. And I just realized I forgot to change the atomic density parameter for implanted nitrogen. So let's go back to the settings, and this I need to change. So let's suppose that my implanted high entropy alloy can accommodate up to 25% of nitrogen, and also that this target with 25% of nitrogen will have the total atomic density of this value. And now I need to calculate the atomic density of the nitrogen at the beginning, and for that I will use this equation, and the details you can find here how to do it. And if I put all parameters into the equation, I will find out that the parameter for the atomic density of nitrogen I need to set as 0.1414. So let's change it here, 1414. So you see it's much different and bigger than the preset one. And I can now run the simulation again with this parameter. Okay, and the implanted depth of the nitrogen should be, oh sorry, I forgot also, I should also change the maximum possible concentration of implanted nitrogen in this target as 25%. And now I can run it. Okay, remove the data, and now the implanted depth should be much closer to the surface with this parameter of density than before, and it will allow to accommodate a maximum of 25% of nitrogen. Okay, so that's all how to run SDTrimSP simulation within this graphical user interface. And as a note, I can quickly show you how to simulate the SDTrimSP without this interface in the console. So as the input file, I will use the same simulation settings, and I can copy this text, which is the settings that which defines the SDTrimSP simulation. So copy, and I will close this graphical user interface now. Okay, and I will create a new folder where I want to simulate this example. Let's call it example. And because I added the SDTrimSP to the path, as I will show you, I did it before. You can see it here. So I can call it from anywhere in my console with just SDTrimSP.exe, and it gives me error because I have here no input file. So I need to create this input file, and content of it will be the one that I copy it from the graphical user interface. Yeah, just like this, and save it. Okay, and now I can run the simulation with SDTrimSP just like this on a single core. You can see it's on single core. If I show you my processors here, so if I run it again, you can see one core is running, and if I want to run it parallel, I can do that. Just to be sure, let me again export the path to the compiled MPI version, and I can run it parallel with this command, for example on 8 processors, SDTrimSP. Now you can see already it's much faster, and let's finish. Okay, once time and again, and yeah, you can see that 8 processors are now running. Now again 0 because it finished. Okay, so that's all how to run ion implantation simulations within the Monte Carlo code of SDTrimSP using the graphical user interface of BCA-GUIDE. Thank you for your attention.